In the face of challenges like climate change, it's common to feel a sense of hopelessness, believing that individual actions won't make a difference. People may think that opting for public transportation over personal cars or turning appliances is consequential, and that activities like planting trees are not impactful. However, this perspective is inaccurate. Some individuals also perceive climate change solutions as too complex for the average person. Contrary to this belief, various solutions exist, so some may not be immediately apparent. The escalating pace of climate change, coupled with global population and income growth, poses a threat to food security worldwide. Agriculture is particularly susceptible to the effect of climate change, with higher temperatures leading to decreased yield of essential crops, and the proliferation of pests, invasive weeds, and disease. This, in turn, adversely affects crop productivity. Green Pioneer is an innovative solution that empowers farmers and communities to fight back against climate change. Green Pioneer doesn't just offer smart agriculture solutions, it fosters awareness and allows communities to become active participants in climate action. Our project is focused on sustainability to tackle challenges related to climate change and its impact on the agriculture sector and raise awareness among the communities. There are various applications available that use AI for crop management and planet identification for smart farming solutions. However, these applications cannot address climate change awareness and promote sustainable farming practice. To fill this gap, our approach to smart farming incorporates additional features that focus on climate change awareness. This sets us apart from our competitors and provides a more holistic solution for farmers. Our project aims to address climate change through two primary dimensions: cultivating awareness and delivering sustainable agriculture service.
Our first innovative aspect is Green Shoot Identifier, the feature of classifying specific types of flowers. A database was used that contains a division into 6 different types of flowers, in addition to another database for seedlings, which are the harmful weeds growing near the crop that consume its resources and food and weaken its production. A dataset was used that classified 12 types of these herbs. The recognition feature is not limited to merely displaying the reading of the image and displaying the descriptive name, but rather provides basic information to the user that enables him to understand the nature of the plant he is dealing with, indicating the appropriate cultivation conditions or the appropriate organic fertilizers and pesticides to deal with it correctly without harming the environment or the rest of the crop. To address the crop loss problem, we are proposing a new feature that utilizes image recognition technology to identify insects and provide users with information in dealing with harmful pests and useful insects. This feature was initially divided into 9 types of harmful pests and 10 types of useful insects. Each image definition displays a brief definition of the insect. If it is useful, its benefit will be described, and if it is harmful, appropriate environmentally friendly pesticide solutions will be suggested that help get rid of it before it spreads in a way that destroys the crop. Since the rice crop is one of the most important national crops in several countries, a special section was created to define common rice disease. The dataset displays 4 different diseases of the rice crop. In addition to a definition of the normal condition, if the farmer has some doubts about something suspicious, the system also displays suggestions for organic fertilizers that helps improve the condition of the crop. The previous 3 features show the stage of monitoring the crop to maintain the quality of production and not lose a large part of the crop. Prior identification of the existing problem and suggestions for environmentally friendly organic solutions that are displayed after each definition of the uploaded image helps to save what can be saved before the disease spread and to avoid problems and lose before it's too late. After that, we reach the post-harvest stage, which requires more awareness than monitoring and study like the previous features. First, most farmers adopt the idea that burning the straw spread on agricultural land helps revitalize the soil after harvesting the crop, and others adopt the idea that burning the volatile residues in the air that end up on their agricultural lands or the waste resulting from these crops, such as straw, is better and the fastest and easiest solution to it. But what is not clear to them is that it's an actual disaster and it's a primary factor in the problem of climate change. Therefore, a Green Guardian section was created that contains a division of 3 different types of waste fires. First, The system displays the type of waste that caused this fire and then alerts them to the extent of its danger and its impact, especially on health. The system also urges him to quickly report this action so that responsible authorities can take appropriate action. We seek to provide this in argument with government agents by obtaining reports containing photos of the accident, its location, and the percentage of damage so that appropriate action can be taken with the perpetrator of these fires, and for the users to have greater enthusiasm for assisting in this report. The Symbolic Rewards feature is added by collecting points that he will then use in our next feature, which is Eco-Friendly Products Marketplace, to help users find a way to reach less harmful products to our planet. It will be promoting a variety of recycled products, helping to create a greener and more sustainable future, displaying eco-friendly products, starting from the popular products that are recycled or manufactured from eco-friendly materials, to fertilizers and pesticides. The system can suggest them in the result of the identification process in the features mentioned, so that users can encourage to use them due to their ease of obtaining. In the end, to address the need to raise awareness beyond agriculture, a special section for global events and environmental awareness tips created so that the user is aware of global events related to environmental issues, especially climate change, useful agricultural tips and guidance, and encourage the user to contribute to increasing the positive impact and stopping harmful wrong habits that he don't realize the extent of impactful.
Our simple environmental lover community, supported by artificial intelligence, displays intelligent and efficient solutions to control crop health and achieve the ultimate yield productivity, taking care of the planet and raising awareness about the problems of climate change and follow-up news and international and local events and conferences. On the homepage, users can search for a group of environmentally friendly products easily. Once choose any of them, detailed information about these products will appear, and the ability to purchase by simply adding it to a cart for a later or favorite list that can easily be browsed and changed as preferred. Then the identifier features types of flowers, seedlings, harmful pests and useful insects, rice diseases and unknown sources, and causative harmful burning. Once the user chooses the partition, he can upload images from his phone or take them directly by the camera and let the system display information about what makes him curious. Finally, once goes to the events section, not only follow up news but will find many guidance videos, awareness and tariff tips, and contribute to user part in maintaining the planet and climate change from the wrong daily habits that may not be aware of its negative effects on the environment. All features are combined at some points. MongoDB has been used to store all the videos and articles on the global event section and data displayed based on the classified image that the user uploaded. They also interact with the backend cloud, which connects with the AI models to predict the results. Firebase is also used to store data about locations for delivery or for Green Guardian reports. Our project primarily relies on AI. We chose AI due to its seamless alignment with the urgency and complexity of the challenges we face. It enables us to offer dynamic, data-driven solutions that can adapt to the ever-changing landscape of climate change. Green Pioneer project methodology. We based the methodology of our Green Pioneer project on combining advanced AI technologies with user-friendly interfaces to provide a complete smart farming solution. The key components of this methodology are AI and machine learning integration. We use advanced AI and machine learning algorithms that analyze data and give actionable insights. These technologies play a significant role in features like smart disease diagnosis, balancing act, and the green shoot identifier, which depend on image recognition and real-time data processing. Data collection and analysis. Data is obtained from various sources, including user inputs, environmental sensors, external databases, among others. This information is then stored in MongoDB and Firebase, where it is processed and analyzed to provide personalized recommendations as well as insights. User-centered design. The design of the user interface is intuitive as well as accessible, ensuring that farmers together with other members can interact easily with the app. Feedback is continuously received from users to further improve on functionality, thus enhancing platform's usability. The collaborative development, agricultural experts, community stakeholders, environmental scientists all work closely together with us to ensure we develop solutions that are pertinent, efficient, and sustainable. Such collaboration, continuous improvement. The AI models and algorithms are regularly updated and refined based on new data and feedback. This iterative process ensures that the solutions remain effective in addressing emerging challenges related to climate change and agriculture.
Looking ahead, we have identified several areas for future development and expansion of the Green Pioneer project to enhance its impact and scalability. Scaling up, we aim to scale up our project to reach more farmers and communities globally. This involves enhancing our infrastructure and developing partnerships to support the widespread adoption of our solutions. Internet of Things integration. We plan to incorporate IoT technologies to collect real-time data from sensors placed in fields. This data will provide deeper insights into soil conditions, weather patterns, and crop health, allowing for more precise and timely interventions. Increasing productivity through waste management, we will implement features to facilitate the sale of food waste or agricultural waste, ensuring that recycling partners can assess these resources urgently. This will not only reduce waste, but also create additional revenue streams for farmers. Using Docker development to ensure scalability and ease of deployment, we will utilize Docker containers for our application. This will streamline the deployment process, improve consistency across different environments, and facilitate continuous integration and delivery. Contracting with recycling partners. Establishing contracts with recycling partners will be a key focus. This will ensure a reliable and efficient process for managing agricultural waste.